Now today we are going to discuss electrochemistry. First topic. First, galvanic cells. Galvanic cells. Galvanic cells are also called electrochemical cells. Electrochemical cells. Electrochemical cells. Like these cells convert chemical energy into electrical energy. Chemical energy into electrical energy. Okay, write down. కాబట్టి galvanic cells అంటే ఏంటవి? ఎలక్ట్రోకెమికల్ సెల్స్. ఈ సెల్స్ ఏం చేస్తాయి? కెమికల్ ఎనర్జీని ఎలక్ట్రికల్ ఎనర్జీగా చేంజ్ చేస్తాయి. ఫర్ ఎగ్జాంపుల్ Zn plus Cu plus 2 gives rise to Zn2 plus Cu, that is equal to 1.1 volt. 1.1 volt. E naught is equal to 1.1 volt. Okay, please write down. E naught is equal to 1.1 volt. కాబట్టి కెమికల్ ఎనర్జీని ఎలక్ట్రికల్ ఎనర్జీగా మార్చే వాటిని ఏమంటామంటే మనం గాల్వానిక్ సెల్స్. కన్స్ట్రక్షన్ ఆఫ్ గాల్వానిక్ సెల్స్ చూడండి. ఇక్కడ మనం ఏం తీసుకున్నామంటే జింక్ సల్ఫేట్ సొల్యూషన్. అండ్ galvanic cell has 3 parts. Galvanic cell has 3 parts. One is reduction of cell. And the second one is oxidation of cell. And the third one is salt breach. Okay, this is zinc rod dipped in zinc sulfate solution. Copper rod dipped in copper sulfate solution. Both are connected through a wire. This is left hand electrode. This is right hand electrode. This is left hand electrode. This is a right hand electrode. Right? This is left hand electrode and that is right hand electrode. On left hand electrode, zinc rod has zinc atoms. Okay, zinc has more tendency to lose electrons than copper. That is important point. Zinc rod has more tendency to lose electrons than copper. Zinc rod has more tendency to lose electrons than copper. Okay, so zinc atoms loses electrons. So Zn2 plus ions, zinc atoms loses electrons, Zn2 plus ions are formed. This Zn2 plus ions enter into the solution. Zn2 plus ions enter into the solution. So solution becomes positive. Zinc rod becomes negative. Zinc rod becomes negative. Okay, this is zinc rod becomes negative. So at anode, oxidation takes place. Oxidation takes place. Oxidation takes place. Why oxidation takes place? Here oxidation state is 0. Here oxidation state is +2. So zinc rod loses 2 electrons. It is converted into Zn2 plus. So at anode oxidation takes place. At cathode, these electrons are moving to copper rod through this wire. Here Cu plus 2 ions are there. Cu plus 2 ions take these electrons and converted into Cu. Cu plus 2 ions రెండు ఎలక్ట్రాన్లు తీసుకుని దానికి కన్వర్ట్ అవుతుంది Cu. This is reduction reaction. Reduction takes place. Reduction takes place at cathode. Reduction takes place at cathode. Okay. So charge wise zinc rod is negative. Charge wise zinc rod is positive. Since these electrons are moving towards copper. So electrons copper వైపు మూవ్ అవుతుంది. ఎలక్ట్రాన్స్ కాపర్ వైపు మూవ్ అవుతుంది అంటే ఇక్కడ ఏ ఛార్జ్ డెవలప్ అవుతున్నట్టు? పాజిటివ్ ఛార్జ్ డెవలప్ అవుతున్నట్టు. జింక్ రాడ్ కాపర్ రాడ్ దగ్గర ఏమన్నా డెవలప్ అవుతున్నట్టు? నెగిటివ్ ఛార్జ్ డెవలప్ అవుతున్నట్టు. కాబట్టి ఛార్జ్ వైజ్ జింక్ రాడ్ ఈజ్ positive, copper rod is negative. That is important. Charge wise, zinc rod is equal to positive. Zinc rod is equal to positive. Copper rod negative. But battery wise, zinc rod is equal to negative, copper rod is equal to positive. బ్యాటరీలో ఎక్కడైతే ఎలక్ట్రాన్స్ ప్రొడ్యూస్ అవుతాయో దాన్ని నెగిటివ్ పార్ట్ అంటాం. కాబట్టి ఇక్కడ ఎలక్ట్రాన్స్ ఇక్కడ ప్రొడ్యూస్ అవుతున్నాయి కదా, కాబట్టి జింక్ రాడ్ నెగిటివ్. బ్యాటరీ వైజ్ జింక్ రాడ్ నెగిటివ్. ఓకే, బ్యాటరీ వైజ్ కాపర్ రాడ్ ఈజ్ పాజిటివ్. సో యూ షుడ్ కన్సిడర్ బ్యాటరీ వైజ్. సో in galvanic cell, left hand electrode is negative, right hand electrode is positive. Cheppandi, in galvanic cell, left hand electrode is negative, right hand electrode is positive. Kabatti you should consider this. You should consider battery wise. Consider this. Okay. Please write down. Okay. Right. So this is, please write down. So in a galvanic cell, left hand electrode is negative. In a galvanic cell, left hand electrode is negative, while right hand electrode is positive. In a galvanic cell, left hand electrode is negative, while right hand electrode is positive. In a galvanic cell, left hand electrode is negative, while right hand electrode is positive. Okay, overall reaction, sir. Overall reaction at anode. Zn minus 2 electrons gives rise to Zn2 plus. At cathode, Cu plus 2 electrons gives rise to Cu. The overall reaction is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. E naught is equal to 1.1 volt. E naught is equal to 1.1 volt. So this is overall reaction. Okay. Next. Work done in a galvanic cell. Work done in a galvanic cell. Work done in a galvanic cell. Work is equal to charge into charge flown into potential. Flown into potential. Okay. Therefore, work is equal to charge flown NF. N ante number of electrons. F ante Faraday. N ante number of electrons. F ante Faraday. 1 Faraday is equal to 96,500 coulombs into E cell. Okay, W is equal to it is coulomb into E cell dentlo untundi volt. Coulomb into volt ne emantam joules. Okay, this is equal to decrease in Gibbs energy. Therefore, delta G is equal to NF E cell. Okay, therefore delta G is equal to minus NF E cell. Okay, please write down. Delta G is equal to minus NF E cell. Okay, completed. Next, what is salt bridge? Sure. What is salt bridge? It's a salt bridge is inverted to containing KCl dissolved in agar-agar. Agar-agar is a gum-like substance. KCl dissolved in agar-agar solution. చూడండి ఇప్పుడు ఎలక్ట్రాన్స్ జింక్ రాడ్ నుంచి కాపర్ వైపు వెళ్తున్నాయి. సొల్యూషన్లోకి Zn2 ప్లస్ అయాన్స్ వస్తున్నాయి. అంతే కదా జరుగుతుంది. కాబట్టి యాజ్ ద Zn2 ప్లస్ అయాన్ కాన్సన్ట్రేషన్ ఇంక్రీజెస్ అంటే సొల్యూషన్లో Zn+2 కాన్సన్ట్రేషన్ పెరుగుతుంది. కాబట్టి దీస్ Zn2 ప్లస్ అయాన్స్ అట్రాక్ట్ దీస్ ఎలక్ట్రాన్స్. So electrons not further moving towards copper. Similarly, here Cu plus 2 ions are converted into Cu. In solution, sulfate ion concentration increases. Sulfate ions pushes these electrons toward zinc rod. So after some time, cell is not working. Okay. So cell is working continuously. When cell is working continuously, salt bridge should be used. Salt bridge contains Ka plus ions and Cl minus ions. Cl minus ions moving towards this and neutralize excess of Zn2 plus ions. And K plus ions moving towards sulfate ions, towards reduction of cell and neutralizes excess of sulfate ions. So this is called electrical neutrality. So salt bridge maintains electrical neutrality. Salt bridge maintains electrical neutrality. Salt bridge maintains electrical neutrality. What is the function of salt bridge? It maintains electrical neutrality. Okay. Next, cell representation. How to represent this galvanic cell? Cell representation. ఇందాక రాశాను కదా, బొమ్మ దగ్గర సాల్ట్ బ్రిడ్జ్ చేసి సరిపోతుంది, మళ్ళీ వేయాల్సిన ఇందాక రాశాను కదా. సెల్ రిప్రజెంటేషన్, సెల్ రిప్రజెంటేషన్, సెల్ రిప్రజెంటేషన్. ఫస్ట్ లెఫ్ట్ హ్యాండ్ ఎలక్ట్రోడ్, left hand electrode, salt bridge and right hand electrode. First ఏం రాయాలి? left hand electrode. తర్వాత salt bridge is shown by two parallel vertical lines. Okay, our right hand electrode. కాబట్టి left hand electrode దగ్గర ఏం జరుగుతుంది? ఆక్సిడేషన్, Zn plus 2 aqua. Salt bridge, Cu plus 2 Cu. This is the representation of galvanic cell. This is the representation of galvanic cell. Please write down. Okay, next potential. In a galvanic cell, oxidation potential is developed at left hand electrode, while reduction potential is developed at right hand electrode, left hand electrode దగ్గర oxidation potential వస్తుంది, right hand electrode దగ్గర reduction potential వస్తుంది. Therefore, electromotive force is equal to E naught cell is equal to E naught oxidation potential plus E naught reduction potential. కాబట్టి EMF is equal to E naught cell is equal to E naught oxidation potential plus E naught reduction potential. ఎలాగో చూడండి, this is zinc sulfate solution and zinc rod. Okay, this is a copper sulfate solution and a copper rod. Okay, both are connected through the wire. The concentration of solution is 1 molar. Concentration of solution is 1 molar. ఓకే, ఇక్కడ చూడండి, జింక్ రాడ్ సర్ఫేస్ మీద జింక్ ఆటమ్స్ ఉన్నాయి కదా, అవి ఏం చేస్తున్నాయి? ఎలక్ట్రాన్స్ లూజ్ చేసుకొని అయాన్స్ గా మారుతున్నాయి, Zn2 plus ions. So all the electrons accumulated on the zinc rod becomes negative, solution becomes positive, and these ions goes into solution. So solution becomes positive, zinc rod becomes negative. So potential developed here is called oxidation potential. When concentration of solution is 1 molar, then this potential is called oxidation potential. Okay, this potential is called standard oxidation potential. When concentration of solution is 1 molar, the potential is said to be standard oxidation potential. Similarly, here solution becomes negative, zinc rod becomes positive. So the potential developed here is called reduction potential. What potential? Reduction potential. When concentration of solution is 1 molar, then it is called a standard reduction potential. Then it is called standard reduction potential. Okay, therefore EMF is equal to E naught cell is equal to E naught oxidation potential plus E naught reduction potential. Okay. Electromotive force E naught cell is equal to E naught oxidation potential plus E naught reduction potential. Completed. So E naught oxidation potential of anode plus E naught oxidation reduction potential of cathode. ఈ ఫార్ములా మీద ప్రాబ్లమ్స్ అడుగుతారు, ఎలా అడుగుతారో చూద్దాము. నెక్స్ట్ standard hydrogen electrode. Standard hydrogen electrode SHE. Standard hydrogen electrode. So this is 1 molar HCl. 1 molar HCl solution. This is platinum wire. Okay, hydrogen gas bubbled through the solution. 1 molar HCl. Hydrogen gas at 1 bar. At 1 bar bubbled through the solution. Hydrogen gas at 1 bar bubbled through the solution. Okay, case 1. When it acts as cathode. At cathode reduction takes place. H plus gives rise to half H2. E naught cell is assumed to be 0. Cell representation. Platinum H plus H2 gas. H plus aqua H2 gas platinum. This is very important. When I acts as cathode, how to represent cell? H plus reduction జరిగించండి. H plus 0. హైడ్రోజన్ ఎలిమెంటరీ స్టేట్ లో ఆక్సిజన్ స్టేట్ అంతా 0 కదా. H plus 0 and platinum. When it acts as anode, case 2. When it acts as anode, half H2 gives rise to H plus. Therefore, దీన్ని ఎలా రిప్రజెంట్ చేస్తాం? సో D naught cell is equal to 0. E naught cell is equal to 0. ఎలా రిప్రజెంట్ చేస్తాం చూడండి. యానోడ్ దగ్గర ప్లాటినం H2 gas H plus aqua. Both are important. దీన్నే స్టాండర్డ్ హైడ్రోజన్ ఎలక్ట్రోడ్ అంటాం. Standard hydrogen electrode. Okay. How to determine standard electrode potentials, standard reduction potential. Okay, this is zinc rod dipped in zinc sulfate solution. This is connected to SHE. What is this? SHE. What is SHE? Standard hydrogen electrode. This acts as, this is 1 molar. This is cathode. This acts as anode. This acts as anode. E naught cell is equal to E naught SRP of cathode plus E naught oxidation potential of anode. Okay, if you measure this, E naught cell is minus 0.76 volt. Therefore, E naught Zn plus to Zn, E naught oxidation potential of anode anta 0. ఎందుకు standard hydrogen electrode 0. Therefore, E naught Zn plus to Zn, this is reduction potential is equal to minus 0.76 volt. This is experimental value. When these are both are connected, here voltmeter is present here. Here potential is developed, reduction potential is developed. This taken as cathode, this taken as anode. Anode potential 0. So the resulting value, unit cell value minus 0.76. This is equal to standard reduction potential value. Okay, please write down. Tomorrow we will discuss Nernst equation and problems.